Guys, so yesterday we talked about different types of ecosystems, and today we're going to be building on that by looking at some of the different abiotic factors that affect different types of terrestrial and aquatic ecosystems. So as we look at some of the different factors affecting ecosystems, we're going to talk first about how different factors are interdependent on each other, specifically how the living, the biotic, and the non-living, the abiotic factors, both affect one another. Then we're going to look at the effects of abiotic factors on terrestrial and aquatic ecosystems. You do need to know the different layers of soil and the different layers of water. And then you also have to be able to describe how lakes behave in different seasons with things like turnover and stuff like that. So biotic and abiotic factors are interdependent in an ecosystem, which means that the actions of the biotic factors will affect the abiotic factors and vice versa. So for example, decomposers, which are biotic, will affect the soil quality, which is abiotic. Or trees, which are biotic, will affect the amount of sunlight on the ground and ground temperature and moisture level in the soil, all of which are abiotic. And then the abiotic factors often limit the size of populations as well as the type and number of species in an ecosystem. So for example, like only certain types of plant life can grow in soils with certain pHs. So we are just going to be mostly focusing on the abiotic factors and how they impact the ecosystem and all of the biotic factors within it. When we're looking at terrestrial ecosystems, we will be looking at soil quality, water availability, temperature, and amount of sunlight. And then with aquatic ecosystems, we'll be looking at the chemical environment, the water pressure, the temperature, the amount of sunlight, and the season. So we're going to start with the terrestrial ecosystems. When it comes to soil quality, that's really referring to like how much nutrients are available in the soil for the plant life to access. The higher the soil quality or the more nutrients present, the more biodiversity you have amongst your plant species, usually the healthier the plant community, you can have larger plants. And different biomes and ecosystems will have different types of soil. Soil is usually less than 2 meters deep, though in some ecosystems it is much less than that. And then the soil is made up of a bunch of different layers with most of the organic matter at the top, and then you have less organic matter as you go deeper. So just kind of an example of how different biomes would have different soil quality. If you think back to when we were talking about the different types of ecosystems, if you remember, the taiga has really high pH, or sorry, really high acidity, which is low pH soil. The muskeg has very low quality soil because of the low rate of decomposition. The grassland has the highest quality of soil because of its high rate of decomposition, stuff like that. As we go from top to bottom in the soil, there are 4 different layers. The first is the litter, which is just the dead leaves and grass. It kind of insulates the soil underneath it. It limits the amount of evaporation that we have from the soil and reduces the amount of temperature change in the soil. And then the topsoil is made of humus, which is decaying plant and animal matter, as well as small bits of rock, air pockets, and water. This topsoil tends to be rich in both minerals and nutrients. This is where most of the nutrients will be absorbed into plants, as well as water being absorbed into plants. And it's where a lot of decomposition happens. The air there is needed for decomposers. If you remember, decomposers use up oxygen during that decomposing process. Topsoil tends to be very dark because the humus, the decaying plant and animal matter, is black. Underneath the topsoil, we have the subsoil, which is more rock and less organic matter, but there is lots of minerals available here, things like iron, aluminum, phosphorus, that kind of stuff. And then underneath the subsoil, we have the bedrock, which, as the name suggests, is a layer of rock. That could be like sedimentary rock, limestone, granite. Soil pH is really important when it comes to what kind of plants are going to be living there. It could be acidic, which would be a low pH, neutral, which would be around 7, or basic, which would be a higher pH. Basic soils are also called alkaline soils. They protect plant life from things like acid rain. Soil pH can be affected by the type of bedrock. So limestone is itself alkaline, so it makes the soil above it more basic, whereas, say, granite is just neutral. The plant life can also affect soil pH, as we talked about in the taiga. Anytime you have decomposing like tree needles, that is going to increase the acidity of the soil or decrease its pH. And then the fossil fuels can also affect soil pH. Anytime you burn fossil fuels, you can produce acid rain, which can then increase soil pH. And then the pH of the soil, like I said, affects what kind of plant can grow there. The second factor that affects terrestrial ecosystems is water availability, which is just how much water is in that ecosystem that can be used by things like plants and animals and stuff like that. The water will also affect the overall climate of the region. If you have a large body of water, that is going to reduce how much the temperature changes between seasons, for instance. It can also increase the amount of precipitation. There's something called like lake effect, which means if you live like downwind from a large lake, you're likely to get more snow in the winter, for instance. The amount of water also affects the plants and animals that can live in that area. So some animals and plants are better adapted to having like less water available, and some plants need lots of water available. Precipitation is one of the big things that affects water availability in the soil. So does just the type of soil present, as well as how deep the groundwater is, or if there's like permafrost, for instance. There's lots of water available in the surface of a muskeg because of the permafrost that's present. And then the deeper the water table, and the water table is like where the groundwater starts, the deeper the water table, the less groundwater is available for like trees and stuff like that. So water in saturated soil is called groundwater. So what that means is if that area of the soil is full of water, it cannot hold any more water. It's like a sponge that has been fully submerged in water. That's the groundwater. Right immediately above that is the water table. The water table is just like the line or the area that separates the saturated soil of the groundwater and the unsaturated soil above it. So what happens is like rain falls on the surface of the soil, it'll sink through the unsaturated soil until it hits the groundwater, and then it will just sit in the groundwater. But when it hits that water table, that is the line that delineates how far it can sink down. Once it is sunk down to the groundwater, then it just sits there on top of the groundwater, becomes part of the groundwater. If the water table is deep, then in order for plants to survive on the surface, there needs to be lots and lots of rain so that the unsaturated soil still has moisture in it. Only trees with really, really deep roots would be able to access groundwater that's really, really deep. Leaching is also worse with deep water tables. So if you remember, leaching is when like chemicals and nutrients and stuff like that from the surface soil get pulled by the water deeper and deeper into the ground until they get to the groundwater. So the problem with that is that sometimes like plant life with really shallow roots won't have access to nutrients because all the nutrients have leached into the groundwater and away from the surface soil. That would be very different from the muskeg, which would have a very, very shallow water table because of the permafrost, which means there's lots of water availability on the surface. The next factor that affects terrestrial ecosystems is temperature, which is part of the climate of that region or the ecosystem. Depending on the biome, temperature can vary greatly throughout the year or be fairly consistent. So for instance, in like a desert, you're going to have fairly warm temperatures year round. Same with in the tundra whereas like a grassland or a deciduous forest is going to have very, very distinct seasons with very, very warm summers and very, very cold winters. Temperature also affects evaporation rates. So obviously, the higher the temperature, the more water will evaporate, which will also affect the plants that live in that area. Organisms who live in ecosystems with really distinct seasons must be able to adapt very well to the temperatures of both seasons or have to be able to migrate. So adaptations to temperature include things like the shapes of leaves or needles, the amount of roots below ground. For animals, the body shape or size, the thickness of the fur, the colors of the fur. So for example, in like the taiga, you might see a lot of animals that can like shift color of their fur from season to season, or can put on more fur in certain seasons, or will hibernate through the winter, stuff like that. And then the last factor that affects terrestrial ecosystems that we're going to be looking at is sunlight. Again, that can be fairly consistent or vary a lot depending on the biome. The closer the ecosystem is to the equator, the more consistent its level of sunlight will be. And the further away it is from the equator, the closer it is to the poles, the more that will vary from season to season. Geographic features can also affect the amount of sunlight. So things like rock outcrops or like mountains can obviously shade an ecosystem. Different biotic factors like the height of plants in that area can also affect that. So obviously the amount of sunlight in a canopy ecosystem will be higher than the amount of sunlight in a forest floor ecosystem. And then the sunlight or the amount of sunlight present will affect what types of plants can live in that area, which then affects the types of animals that can live in that area. So some plants are more shade tolerant, they're able to survive on the forest floor. Other ones are not shade tolerant and will be outcompeted by larger trees that can access the sunlight. The amount of sunlight also affects the amount of evaporation that is coming from the soil. If it's shaded more, it's not going to have as much evaporation and will also affect the temperature. Okay. Now we're moving on to our aquatic ecosystems. The first factor that we're going to be looking at for that is the chemical environment. So that includes whether the ecosystem is freshwater or saltwater. Most organisms can only survive in either freshwater or saltwater, though there are some, like bull sharks, that can survive in both. The amount of oxygen is also part of the chemical environment. When we looked at the different zones of a lake, we talked about how like the profundal zone has low oxygen levels. And so that is going to affect what types of species can survive there. The amount of dissolved oxygen is dependent on the temperature as well as the water depth and the amount of other dissolved substances. We talked about before how the warmer the water is, the less gases it can dissolve. So warmer water holds less oxygen in it, whereas colder water would hold more oxygen in it. Obviously, the deeper you go, if you move away from where photosynthesis can happen, you're going to move away from where there is oxygen. And then the more other dissolved substances, that also means less oxygen because there is a limit to how much dissolved stuff water can hold. And so if it is holding more other dissolved substances, like say nutrients or nitrates, that means there's less room to hold oxygen. And then also just the presence of other chemicals is part of the chemical environment. So if you have certain pollutants or like nitrates and phosphates from fertilizers, that's also going to affect the ecosystem. Obviously, we talked previously about how some substances can promote the growth of species, like how having phosphates and nitrates in your water can cause algal blooms, for instance. The next factor that affects aquatic ecosystems is water pressure. Water is about 800 times more dense than air, so that's why it's like harder to like walk through water than air or move your hand through it. And water is also a lot heavier than air. If you've ever tried to like carry a big bucket of water as opposed to carrying, a bucket that's filled with nothing but air. Obviously, water is much heavier. So at a depth of 10 meters, the pressure is about twice that as what it is on the surface. And the pressure of the water increases by about 100 kilopascals every time you go 10 meters deeper. So species are usually adapted to only survive at like a given pressure range. If like an organism that normally lives at like close to the surface of the ocean were to be brought deeper, it would be like crushed. Its skeleton wouldn't be able to withstand the pressure. And on the other hand, if you took something from very, very deep in the ocean and brought it up to the surface, it would just like expand outwards because it's not used to having that little pressure pushing in on it. So either one of them would die if they got moved to the wrong pressure. And then as far as temperature and sunlight, just like with terrestrial ecosystems, that can vary greatly depending on the year and also depending on like how far away from the equator this ecosystem is. But it can also vary depending on depth. So obviously the deeper you go into a body of water, the cooler it's going to get, at least when the surface isn't frozen, I should say, and the darker it's going to get. Areas with more sunlight that are warmer are obviously going to have more plant life. You obviously need sunlight for photosynthesis to occur, and a lot of plants that live in the water are not adapted to survive in the cold. Even areas that have no sunlight that are very cold will still contain life. You can have things like chemoautotrophs, which are producers that don't require photosynthesis. They just need certain chemicals to be present, like sulfides and stuff. And then the seasons, especially in places like Canada that have really distinct warm and cold seasons, this is really, really important for lake ecosystems, which tend to freeze over in the winter and then thaw in the summer. So as water cools, it becomes more dense, just like most substances, until it reaches 4 degrees Celsius. And then as water continues to cool past 4 degrees Celsius, it actually starts becoming less dense again. So that's why ice floats. It's less dense than liquid. And it's also why, as long as the lake is deep enough, the bottom of the lake will be 4 degrees Celsius. 4 degrees Celsius is the most dense temperature of water. And then depending on different seasons, the water in the lake is going to behave differently. So this is just kind of a diagram of the density of water on our y-axis and the temperature on our x-axis. So 4 degrees Celsius, which is right here, has the highest density. As you cool from 4 degrees back to 0 degrees, which is where ice would form, you're decreasing density. But also as you warm from 4 degrees and get warmer and warmer and warmer, you're also getting less dense. So anytime you move towards 4 degrees Celsius, you're getting more dense. Anytime you move away from 4 degrees Celsius, you're getting less dense. And this is just an example of what the temperatures in a lake could look like in different seasons. So in the summer, the bottom of the lake is going to be about 4 degrees. And then as you move towards the surface, it's going to get warmer and warmer and warmer. In the winter, the bottom of the lake is still 4 degrees, but as you get towards the surface of the lake, you move towards 0 degrees Celsius, and then the ice on the top is obviously below freezing. So during Canadian winters, lots of lakes will freeze as long as there's not too strong of a current. That does prevent oxygen from dissolving from the air into the water. If light can penetrate the ice, if the ice isn't too deep and there's not too much snow on it, then photosynthesis can continue and produce oxygen to sustain some of the life underneath. If not, then photosynthesis will stop and the oxygen levels will just decrease and decrease, which can result in some of the species dying off or having to like hibernate through the winter. Underneath the ice, the water is arranged in layers based on its density. which is based on temperature. So the least dense water will be right below the ice. It'll be just slightly above freezing, so maybe like 0.01 degrees Celsius or something. And then the most dense will be at the bottom of the lake. It'll be 4 degrees Celsius. In the summer, the surface water will be way above 4 degrees Celsius. And as you move deeper, the water will get cooler and cooler. If you've ever been in the lake in the summer, you know this. When you're like swimming on the surface of the water, it's nice and warm. But if you like stick your feet down, it feels a lot colder down there. And then once again, the coolest and most dense water will be at the bottom, and it will be 4 degrees Celsius. Yeah. This does mean that there is not a lot of movement of oxygen from the surface into deeper water during the summer. But we're going to talk about how we do have oxygen moving deeper into the water. First, let's look at some of the layers that form in both the winter and the summer in lakes. So you have the epilimnion, which is the uppermost layer of liquid water. So it doesn't include the ice in the winter. So it's the surface of the lake in the summer and then just below the surface of the ice in the winter. It is the least dense form of liquid water. It'll be the warmest in the summer and the coolest in the winter. Then we have the hypolimnion, which is the lowest layer of water down at the bottom of the lake. It'll be the most dense layer of water, and it will be 4 degrees Celsius in the summer and the winter, as long as the lake is deep enough to like have that much transition happening. And then the thermocline is just a narrow zone between the epilimnion and the hypolimnion where temperature changes really rapidly. Okay, so let's talk about how oxygen gets moved deeper into lakes. This happens in both the spring and the fall. In the spring, the ice on the lake melts and oxygen starts to dissolve into the water. And remember, in the winter, the coldest water is at the top, right below the ice. But once the ice melts and the sun starts to warm up that water, it's going to go from 0 degrees to 1 degrees to 2 degrees to 3 degrees. And then it's going to hit 4 degrees Celsius, where it becomes the most dense form of water, and it is going to sink to the bottom. When it sinks to the bottom, it's going to push up the layers from the bottom towards the surface. And so the layer in the lake that was 1 degree now gets pushed to the surface. It wants to 2 degrees, 3 degrees, 4 degrees, sinks to the bottom, and all the layers underneath it get pushed up. And so every time that water that's on the surface hits 4 degrees and sinks to the bottom, it's bringing the oxygen that dissolved into it to the bottom as well. So that process is called spring turnover. It's really important because it's the only way that deep lakes get oxygen to the bottom of the lake. This also happens in the fall, though for slightly different reasons. Remember, in the summer, the warmest water is on the surface. So say we have like 8-degree water on the surface. As winter starts to approach in the fall and it gets cooler, that water on the surface is going to cool from 8 degrees to 7 to 6 to 5 to 4. And when it hits 4 degrees, it is now the heaviest water possible, and it sinks to the bottom. And when it sinks to the bottom, it's going to push up all the water from the bottom. And so now we have 7 degrees water on the surface, and it's going to warm from 7 to 6 to 5 to 4. Now it's heavy, it sinks back down again. So that's called fall turnover. Once again, it's bringing the oxygenated water from the surface of the lake deeper into the lake. So these are the 3 different layers within the lake. So the epilimnion at the top, the hypolimnion at the bottom, and the thermocline in the middle. And then in both the spring and the fall, we will have turnover occur where in the spring, the water that was the coldest, so was like 0 degrees, warms up until it hits 4 and then sinks to the bottom. And as it sinks to the bottom, it pushes everything else up. In the fall, same kind of process, but we have the warmest water on the surface, and it's going to cool until it hits 4 degrees and then sinks and pushes everything else. And whatever's on the surface cools until it hits 4 degrees and then sinks. Okay, that is it for today's lesson. Make sure that you have a good understanding of the different layers of the lake, different layers of the soil, and all of the different factors that affect these different ecosystems. Let me know if you have any questions.